Hello and welcome to the Screencast introducing the special number e. Every exponential function of the form f of t equals b to the t, where b is greater than 1, exhibits nearly identical behavior. The function passes through 0, 1, always increases, and is always concave up. The value of b primarily impacts how fast the function grows. Because of these similarities across a wide range of values of b, it turns out to be useful to choose a single special base that we will denote e, and use horizontal scaling to represent any exponential function of the form f of t equals b to the t by instead writing f of t equals e to the kt for an appropriate value of k. The natural base e is a very special number that has several important properties. For now, a good way to think of e is that it's an irrational number that is approximated by 2.71828. This base generates the natural exponential function e to the t, which turns out to have many important properties and to play a prominent role in calculus. One of the function's most important characteristics is that its output value tells us not only the height of the graph at the given input, but also the rate at which the output value is changing with respect to changes in the input. One of the main advantages of moving to a single base will be seen in subsequent sections where we seek to find the exact values of the constants a, c, and k in functions of the form g of t equals ae to the kt plus c that model phenomena in the world around us.